Hello, coordinate algebra students. We are going to finish up your EOC review packet today. So we are picking up at number 61. The original function is y equals f of x. If the function translates 6 units to the left and 4 units up, which function represents the translation? All right, so 6 units to the left, that's a horizontal shift, and up 4 units, that is a vertical shift. So you've got to remember that HRVD, so the easy thing I think is the vertical shift. Remember, vertical shifts, you obey the signs, and they are found in the back of equations. So just looking at the up 4 units, you could eliminate 2 answer choices because they are shifting down 4. Hopefully you guys are saying get rid of C and D. So left 6 units. So 6 units to the left. Remember, those go in the opposite direction. So left 6 is like -6, but inside it would be the opposite sign. So if it was -6 and it goes in opposite, then you need a +6 on the inside. So the answer would have to be B. This is right 6, and this is left 6. All right, so which translation rule moves the top figure to the bottom figure? All right, so we are going, so if you just compared some, 3, 4 is moving to 3, -2. All right, and let's see, let's check out another one. How about 5, 2? 5, 2 moves to 5, -4. So really the change is happening in the y values. Notice the x's are staying the same. So I need a rule that makes x stay the same, and my y values, 4 goes to -2. So how do you go from 4 down to -2? Hopefully you're saying -6. So x's stay the same, and my y's are subtracting by 6. All right, look, that's a 2. 2 minus 6 is -4. So the correct answer here would have to be A. Number 6, a triangle in the coordinate plane has coordinates 2, 3, -4, -5, and -2, 4. It is reflected about the y-axis. What are the new coordinates? So you need to know the rule for a y-axis reflection. So if you forgot your rule, okay, let's just look. If I had this point right here, I'm just going to name that one 1, 2. If it flips over the y-axis, it goes over here. Okay, what would that new point be? -1, +2. So if you forgot your rule, what happens? X, Y, the y's stay the same, the x's change signs. So the rule is -x, y. All right, so in the first one, 2, 3, it would need to become -2, 3. -4, -5, the x changes signs. It would be +4, -5. And the last one, the x changes signs. -2 would become +2, 4. So which of these has those coordinates? And that is A. 64. When trapezoid number 1 is translated to trapezoid number 2, what are the new coordinates of the point 0, 0? Okay, so this corner is actually coming over here, right? So we want to figure out what are those new coordinates going to have to be, okay? So if you look, this is hard to see, but this is -8. So what's happening is this is going, it's going left. So it's going from -2 to -8. So it's going left 6. Okay, -2 needs to go to -8. So that's -6. And then it's also shifting down. It was at 8. So it's shifting down 8 and 8. If this point, I'm sorry, I'm looking here. I'm comparing, right now I'm just comparing this point to this point. It went left 6 and it went down 8. Okay? So if I can compare this point to this point and see left 6 down 8, that means this point is also going to go left 6 and down 8 to give you -6, -8 for your coordinate. So the correct answer would be D. All right, 65. Which of the following lines are perpendicular? So you have to remember some parallel and perpendicular things. So parallel lines, they have the same slope. And perpendicular lines, they have opposite reciprocals. Okay, so let's see. Which of those are going to be opposite reciprocals? So the only negative one I see is line C. So I'm going to need to use that because all these others are positive. So I've got to have at least one negative. So -2/1, if you flip it, it would become +1/2. Okay. So which lines are perpendicular? Ooh. So line A and line C. So here and here. The other option to go with C is line B, and that doesn't work, right? Line D is also perpendicular to line C, but that's not an option for us. Okay, so A and C, because D is not an option to go with C. All right, so A and D, those would be parallel. All right, so moving on to 66. What is the slope of a line parallel to the graph? So you need to find the slope on the graph. All right, rise over run. We're going up 3, right 1. So 3/1. So we're looking at a slope of 3 of the given line. Well, parallel slopes are the same, so we need a slope of 3 because it needs to be the same. If it asked for the perpendicular, it would be the opposite reciprocal. So that was +3, so it would be -1/3. Okay? All right. So my next one, 67. I don't know if I have extra room. So 67 is one that I like to draw. I like to draw pictures here, okay? If you have graph paper or just scratch paper, you could do this. I don't know if I can move. Let me see if I can move this down. I can. Yay. Okay. I'm going to move these down some to give me a little bit of room. So just bear with me a second. All right. So I'm going to draw a picture here. So if I am just kind of sketching where this would go on a grid, okay, I'm going to do this here. So like 1, 1, that would be about right here. So we think that would be A. That's 1, 1. I'm just kind of making a rough sketch. B would be 1, 3. That might be up here. I'm trying to find, so I've been given 3 coordinates of a rectangle, and I'm trying to find coordinate D. So what you know about rectangles is they have opposite sides are the same length, right? So if A is 1, 1 and B is 1, 3, and then I have C is 4, 3, that's going to be up here, right? Over 4, up 3, which is the same height that B was. So that's C at 4, 3. I need to figure out what D's got to be. Well, here's part of it, right? So D is going to have to connect here and create the rest of that rectangle. So it's going to have to be at the coordinate that makes these be the same length, right? So the x coordinate here is 4, so D is going to have to be at 4, and it's going to have to go up how high A is, 1. And it's just easy if you draw a picture to see that. Okay. So 68. 4 students are working in a group and are asked to find the length of BC. Who set up the problem correctly? Okay. So this is a right triangle that has a leg length of 3 and another leg length of 4. So you could use Pythagorean theorem here, right? So if we did 3 squared plus 4 squared equals x squared, okay? So there's Pythagorean theorem. Let's see, Jimmy did it right. But look at my answer choices. I've got multiple people here. Alice is out. Alice didn't really know what she was doing right there. So any choice I see that has Alice, I'm going to eliminate. Smart test taking, process of elimination for some of them. So Jimmy, look, here's Jimmy. He's here and here. So we got Jimmy. So now we need to figure out, what about Mo and Jane? Well, that's square root. That looks like distance formula. So let's see. So the distance from C to B. So C is 1, 2, 3, 4, 1. D is 1, 5. Okay, so if we were to do the distance formula, it would be so they're starting with 1 and then going to 4. So it would be 1 minus 4 squared plus 5 minus 1 squared. And there's a relationship here. See, like right here, if I go back to my Pythagorean theorem, I get 9 plus 16 equals x squared. So what you end up with here, if you were to just square root this, it would be the square root of 9 plus 16 equals x. The square would go away. Could you square root that? So if you were to look right here, you could figure out who's doing it right. That would give you 9 plus 16. Ooh. This gives you 9 minus 16. So the thing about the distance formula is you got to have the plus sign in the middle there, okay? The plus sign in the middle. And if you notice, Jane is subtracting. Distance formula doesn't subtract in the middle. Distance formula adds, just like Pythagorean theorem adds. So the correct answer here is Mo and Jimmy. 69. On a coordinate grid, the movie theater is located at 0, 0. The mall is located at 4, 3. If the bowling alley is located at the midpoint between the theater and the mall, what is the approximate distance from the bowling alley to the mall? Okay, so I've got the movie theater, and then I've got the mall, and the bowling alley is in the middle. Okay, so if I drew a picture, it's like, here's the theater. That's at 0, 0. And over here at 4, 3, that's the mall. Okay, so halfway in the middle is the bowling alley, right? Well, we need to figure out what that is, because what it's asking is for the distance from the bowling alley to the mall. Well, I can't find the distance from the bowling alley to the mall. Well, you kind of have a couple options here, but the easiest thing is going to be find the coordinates of the bowling alley. The bowling alley is halfway, right? So I'm going to find the midpoint first. So remember, that's x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, so in this case, I am looking at 0 plus 4. I'm going to run out of room. Let me see if I can move. Oh, those are all connected. Okay, I'll work on that underneath, so just bear with me. So 0 plus 4 over 2, 0 plus 3 over 2. So I'm looking at 0 plus 4 is 4. 4 divided by 2 is 2. And then 0 plus 3 is 3. 3 divided by 2 is 1.5. So the bowling alley is at 2, 1.5. So I want to know the distance from here to here. Okay, so next would come, and I'm just going to need to scroll down. Now I need to find the distance. I want the distance, it says, from the bowling alley to the mall. So the distance from 2, 1.5 over to 4, 3. Okay, x1, y1, x2, y2. So I'm looking at the square root of x2 minus x1, 4 minus 2 squared, plus y2 minus y1, 3 minus 1.5. squared. Okay. Scroll down a little more. So this is the square root of 4 minus 2 is 2, so 2 squared, plus 3 minus 1.5 is 1.5 squared, right? So that is 4 plus 2.25. So it's the square root of 6.25 when you add them, which is going to give you 2.5. So it's 2.5 units. I'll leave this here for a second. You can always pause if you need to. 2.5 units, and each unit is 1 mile. So the correct answer is 2.5 miles. Okay, so I told you before I worked through this problem, I told you there were a couple ways that you could do this. So this was the first one. You could find the midpoint and then find the distance from the midpoint to the mall. All right, but then really, if you wanted to save some work, let's just think for a second. We're going from the mall, so from the theater to the mall, we have those coordinates. And the bowling alley is exactly halfway, and we just want to know the distance from the halfway point to the mall. So what you could have done here, rather than finding the midpoint and then finding the distance from the midpoint to the other end, you could have found the distance from the theater to the mall and divided it by 2 to get half the distance from the halfway point to the mall. And so let's see what that would do. If I found the distance from the mall to the theater, that's 4 minus 0 squared plus 3 minus 0 squared. Okay, that is 4 squared, that's 16. 3 squared is 9. Square root of 25, which is 5. So what that means is from the mall, from the theater to the mall, I'm going to just come back over here and write, from the theater to the mall is 5 total units, right? Well, if the bowling alley is halfway, the bowling alley is going to be 1/2 of 5 units, and 1/2 of 5 is 2.5. Okay, so that's a little bit quicker than finding the midpoint and then doing the distance formula again. Since the bowling alley is exactly halfway, then you take the distance and divide it by 2. Okay, that's just another way you could do that if you thought about that, to do it that way first. Look at the quadrilateral W, X, Y, Z on the right. What are the coordinates of the midpoint of X, Y? Okay, so the midpoint coordinates of X, Y. So you need to know the coordinate of X. So X is -1, 6. Y is 5, 2. And you're finding the midpoint. Okay, you add the X's and divide by 2. So -1 plus 5 divided by 2. And then you add the Y's and divide by 2. 6 plus 2 divided by 2. So -1 plus 5 is 4. 4 divided by 2 is 2. 6 plus 2 is 8. 8 divided by 2 is 4. So 2, 4. So that's about right there. Okay. All right, 71. A right triangle. A right triangle is formed by the points 2, -1, 2, 5, and 6, -1. Find the length of the hypotenuse, which is the line segment BC. Okay, so best thing here is BC is your hypotenuse. So AB is going to connect together. So I'm going to draw, let me see if I can get some more room. Nope, those are connected there. Okay, let me scroll these down. Scroll down what I can at least. And move that down. I'm going to write at the top. Okay, so from A to B. So if I drew my picture, if A is at 2, -1, I know B is at 2, 5, so that's going to be up here. Okay, that's 2, 5. So I've got that. And C is at 6, -1, so that's over here, okay? All right, and it's a right triangle. So here's my hypotenuse. That would be your C, right? So if I'm going from 2, -1 up to 2, 5, my y's are changing. What's the distance here? From -1 up to 5, you could count that. That's a distance of 6, right? And from here, from A to C, the change here happens in the x values. If I go from 2 to 6, that distance is 4, okay? If you can't do this, you do distance formula from B to C, okay? I'm going to use Pythagorean theorem. So what I get is 6 squared plus 4 squared equals C squared. That's 36 plus 16 equals C squared. 52 equals C squared, and you take the square root of both sides, and what you get is C equals 7.2. Okay, notice I don't see that on any of these, okay? So I need to figure out what these radicals are going to be equivalent to. So I'm going to do 2 times the square root of 10 in my calculator. I'm going to do 2 second x squared to open up the radical button, and 10. That's 2 times the square root of 10, and I get 6.3. So that's approximately 6.3. He's out. 2 second x squared to get to the square root, and a 2. So 2 times the square root of 2, I get 2.8. He's out. So hopefully it's D. I do 2 second x squared and 13. 2 times the square root of 13, and that is, approximately 7.2. There's my answer. So I used Pythagorean theorem. If you don't know that, if you couldn't figure out these sides over here, you would literally just use the 2, 5 for B, and you would use 6, -1 for C, and you would plug it into the distance formula. So it would be the square root of 6 minus 2 squared plus -1 minus 5 squared. Okay, you end up with the square root of 6 minus 2 is 4. 4 squared is 16. -1 minus 5 is -6. -6 squared is 36. Okay, notice these are similar. These are the same numbers, 36 and 16, right? That's the square root of 52, which is approximately 7.2. Okay. All right, 72. Ethan wants to purchase a rectangular lot at a lake resort. He drew the layout of the lot on a coordinate plane where x and y values represent the length in yards. Okay, so the center of the lot is located at 0, 0. The northeast corner of the lot is located at 16, 13. The southeast corner of the lot is located at 16, -13. Northwest is -16, 13. Southwest is -16, -13. What is the area of the rectangular lot? Okay, so basically what's happening, my center is at 0, 0. Okay, so you need to know it's got some directions here, north, east, south, and west, right? All right, so it says the northeast corner, that's over here, this way, okay? Northeast is at 16, so we'll make that called 16 up to 13, okay? So there's that, 16, 13. Then the southeast, that's down here, is at 16, -13. Okay, we'll call that -13. It's down here. So that is 16, 13. That's 16, -13. So could we figure out the total length of this side right here? All right, so really what's happening is this is 13 units, this is 13 units for a grand total of 26 units over here on this side, right? So then let's see. The northwest corner, northwest is up here, is at -16, +13. That's up here. -16, 13. So I can now connect this way. And then the other is at -16, -13 down here. So here we go. I've got a rectangle. I have a rectangle that has side length. If that was 26, that's 26, right? And I'm going, this is 16 units and this is 16 for a total of 32. So it says, what is the area? So area is length times width. So in this case, it's going to be 32 times 26. Okay, so you're going to have to plug that in. 32 times 26, and you should get 832 yards squared. Sorry about that. All right, 73. What is the approximate distance from point D to the origin? So you got to know what the origin is, right? All right, so the origin is the point 0, 0. So we're trying to go from 0, 0, which is right here, over here to point D. That's this distance. Can I draw a triangle? Yeah. 1. So up 1, I'm making a right triangle. 1, 2, 3, 4, 5, 6, 7. All right, so I've got 1 squared plus 7 squared equals c squared. I'm using Pythagorean theorem. 1 plus 7 squared is 49 equals c squared. So 50 equals c squared, and I take the square root of both sides. So when you do the square root of 50, you get approximately 7.1. Well, this says approximate distance. So I need to round it to the nearest whole number. So the correct answer would be A, 7 units. All right, so number 74, which expression represents the perimeter? All right, perimeter at all sides of the rectangle shown. Okay, so I need to know the length here. All right, y'all think about this. Horizontal, from left to right, okay, those are x values. So we want to see how are these x's changing. So I go from 0 over to p, 0 over to p. Well, that's just p units. Okay, I don't know what that number was. If that was a 3, this length would be from 0 to 3, which would be a 3, right? If that were a 10, it would be 0 to 10, and it would make this 10. We just don't know what that is. So we just call it p, whatever it is. It's a variable, but whatever that is, this is the same. Okay, so now when I look vertical here, vertical, those are y values. So I'm going from 0 up to r, 0 up to r. Okay, well, if that were a 5, from 0 up to r, it would make this be 5 units tall, right? But we don't know what r is representing. So the height here is just going to be r and r. So when I add all the sides up, I get r plus p plus p. Well, that's 2 r's plus 2 p's. Correct answer is C. All right, we're getting there. 75. Estimate the area of the trapezoid shown. So the formula is 1/2 of base 1 plus base 2 times the height. Okay, so base 1, we need to figure out how long is the base. 1, 2, 3, 4, 5, 6, 7. How long is this one? 3. So then how tall is this trapezoid? Okay, how many units tall is this? So that is 2 units tall, right? So we plug in 1/2 times base 1. Well, that was 7, plus base 2, which was 3, times the height of the trapezoid, which was 2. All right, parentheses first. So 1/2 times 10 times 2. Okay, so 1/2 of 10, that's 5, and 5 times 2 is 10. So we're looking at 10 square units. Okay. All right, let's see if I can move this down because I'm going to need more room there with 76 for sure. All right, I can move 77 and 78 down. All right, so we are partitioning. So we have a ratio, a 5-to-3 ratio. All right, so little a is 5, little b is 3. Of A to B, here's x1, y1, x2, y2. All right, so your partitioning formula. So you need A over A plus B. So that's 5 over 5 plus 3, which is 5 over 8. So that is the distance. That's my 5/8. Okay, that's where we're partitioning. So here we go. So let's just do this. So I've got 5/8. X's come first. So x2 minus x1. So 4 minus -4. And then we have plus -4. Then we do the same thing. 5/8. Then we do my y's. y2 minus y1. -10 minus -2 plus y1, which is -2. Okay. All right. So let's see. I got some positives right here. Minus negatives become positives. So let's get down to the next section here. Here we go. So I get 5/8. I'm going to combine 4 plus 4. That's an 8. Plus a negative is just a negative. -4. Comma. 5/8. I combine here. -10 plus 2. It's -8. -2. All right, if you were in Miss Jones's class, at this point, we plug straight in for each of these. Okay, so what we do is we do 5 divided by 8 times 8. We press enter and we hit -4. Okay, but you may not do that. You may do piece by piece. And if you do, that's okay. If you do 5 divided by 8 times 8, if you go ahead and do that part first, you're going to get a 5, and then the -4 stays. Then over here, 5 divided by 8 times -8. That's going to give you -5. -2 stays. All right, so one more. 5 minus 4 is 1. -5 minus 2, -7. So 1, -7 is your answer. And that is A. We did it. All right, number 7. What is the perimeter of BDE? Okay, so here we go. So BE, 1, 2, 3, that's easy. 4, right? Okay, so now I need to do these others. So I got to make some triangles. All right, that is a, I don't know why that moved. All right, so this is 2 and 1. All right, so I'm looking at, for this section, 1 squared plus 2 squared equals c squared. 1 plus 4 equals c squared. So that's going to be a 5. So when I square root both sides, I get c equals the square root of 5. Okay, so square root of 5 goes there. So I know I'm going to have 4 plus square root of 5. Can I get rid of some stuff? Yep. None of those have what I need, right? And you can plug in if you need to check. So now let's see this one. 2, 1, 2, 3. All right, so that's 2 squared plus 3 squared equals c squared. 2 squared is 4 plus 9 equals c squared. That's 13 equals c squared. Take the square root of both sides. C equals the square root of 13. There you go. Plus root 13. So we just use Pythagorean theorem. And if you want numbers, you can always make those decimals, those radicals decimals, and then come back and check against these. Okay. All right, so last one. On the coordinate grid of a map, Jeff's house is located at 9, 5. Hannah's house is at -5, -5. Kenya's house is located at the midpoint. What is the distance from Hannah to Kenya? All right, so you have Hannah's over here. Hannah's at -5, -5. All right, Jeff is over here at, Jeff's way over at 9, 5. Okay, Kenya's halfway in the middle. We don't know what her coordinates are, and we want to find the distance from here to here. But we know she's halfway, right? All right, so let's just do this. Instead of finding the midpoint and finding the distance, can we find the total distance from Hannah to Jeff? All right, so let's find the distance from Hannah to Jeff. All right, so distance, we're doing Hannah to Jeff. That's 9 minus -5, squared, plus 5 minus -5 squared. Those all become positives. So I get the square root of 14 squared plus 10 squared. Okay. So 14 squared is 196 plus 100. It's the square root of 296. Okay? So that's about 17.2. All right. So what this is from Hannah to Jeff. Right? So I'm going to come right here. Let's just say from Hannah to Jeff, that total distance is 17.2. So what do we know about from Hannah to Kenya? From Hannah to Kenya, oh, that's a K, not a T. It's going to be 1/2 of that distance. And it's 1/2 of that because Kenya is at the midpoint, right? The midpoint is the middle or the halfway. So 17.2 divided by 2 gives me 8.6 miles. You can find the midpoint and find the distance from the midpoint to the end if you want, or just find the total distance and divide it by 2 since it's midpoint. All right, so that is it. That's your last problem. Good luck studying for your EOC.